So, welcome to this first session of Formulae, Stoichiometry, and mole concept. So, let me hope my screen is visible. So, in this series of lessons, which I'm going to conduct, so we have this brief outline. So, we shall look at the concept of a mole. I am doing some groundwork trying to prepare you for the items that I'll discuss later on. So we shall discuss concept of a mole. What do we mean by a mole? Then we shall also look at molar mass of different compounds, which is also kind of related to formula mass. Then we shall also look at relations and mole conversions. Mole conversions, here we can look at converting from mass to moles, moles to particles, moles to volume. So all those related conversions shall be discussed. Then we shall also look at empirical and molecular formulae. Then stoichiometry. So stoichiometry, we relate quantities of products and reactants in a well-balanced chemical equation. So I start with the concept of a mole. So this is kind of a motivation. So I start with this image support, kind of a support item. You normally interact with dozens, normally in your daily life. For example, here I've given an example of eggs. If you have 12 eggs, that is 1 dozen. So a dozen, in simple terms, it is a counting number. A counting number, in particular, 12. So here we have that 1 dozen of items. This is information which you interact with on a daily basis. So before we understand what a mole is, we build from what we know. We build from what we know, as in, you know what a dozen means. That a dozen of items contains 12 items. In particular, we say that 1 dozen of items is equal to 12 items. For example, 1 dozen of books is equal to 12 books. Similarly, 1 dozen of bottles is equal to 12 bottles. In summary, a dozen is a counting number, in particular, 12. So you know what this dozen is. So using the concept of a dozen, now we introduce the concept of a mole. So since a dozen is a counting number, a mole similarly is also a counting number. However, for atoms, since for atoms, ions, molecules, etc., all these are very small particles, we cannot view an atom. We just have its structure representation. Same applies to ions. Same applies to molecules. We can come up with their structure representation, but their actual look is very difficult to come up with. Why? These are very small things. So we cannot, since these are very small things, we cannot talk about them in terms of dozens. Understood? We cannot talk about atoms, ions, and molecules in terms of things that are countable. These are very small things that are difficult to count. So we cannot say that 1 dozen of atoms equals 12 atoms. No. For atoms, ions, and molecules, we use the concept of a mole. That is, so by definition, we say that a mole is a quantity of matter that contains 6.02 times 10 power 23 particles. We call this the Avogadro's constant. So in particular, we say that 1 mole of a substance contains 6.02 times 10 power 23 particles. The particles can include atoms, ions, or molecules. So for atoms, ions, and molecules, to count them, since they are very small, to count them, we use a standard number known as the Avogadro's constant. So the Avogadro's constant is this number which you are seeing, 6.02 times 10 power 23 particles. So when we are discussing about a mole we simply mean, by a mole, you can relate it to a dozen. A dozen we simply mean 12 items. That is a dozen. Now for a mole, we simply mean 6.02 times 10 power 23 particles. Now this is a very big number. Hope you agree with me that this is a very big counting number. So it is a standard number known as the Avogadro's constant. So I give some few examples. In particular, 1 mole of calcium atoms, like the other case for a dozen, 1 dozen of books. 1 dozen of books equals 12 books. So here we shall say 1 mole of calcium atoms is equal to 6.02 times 10 power 23 atoms. Similarly, also 1 mole of oxygen molecules is equal to 6.02 times 10 power 23 molecules. Similarly, 1 mole of hydrogen ions is equal to 6.02 times 10 power 23 ions. So that is the concept of a mole. Next, we have the molar mass. Hope the concept of a mole has been understood very well. How have I explained this? I have built this from what you know. What do you know? You know a dozen. You know a dozen as what? A dozen as a counting number. That if I have a dozen, I mean 12 items. Then if I have a mole, what do I mean? If I have a mole, I have 6.02 times 10 power 23 particles. Those particles can be atoms, ions, and molecules. So for atoms, ions, and molecules, we do not use dozens. Why? We do not use dozens because these are very small things. These are very small things. So to count them, we use the concept of a mole and relate it to the Avogadro's constant. Hope that is understood very well. Next we have, I have told you that in these first videos, I'm going to, like 2 videos, the first one and the second one, I'm going to do some bit of groundwork. I cannot simply start with the items before going through these things. I taught these things, but you forgot. That one I'm so sure you forgot. So we have molar mass. So molar mass, by molar mass, we mean the sum of atomic masses of atoms present in a compound. A compound, for example, if I have water, all of you know that water is H2O. So molar mass of water, to get molar mass of water, I add the mass of hydrogen and so I sum the atomic mass of hydrogen plus that of oxygen. Then overall, what I get will be the molar mass of water. And I'm going to give some few examples here. For example, here, work out the molar masses of the following compounds given this information. So to calculate molar mass, listen attentively, to calculate molar mass, they will always give you the atomic masses. For example, here we want to work out the molar mass of sulfuric acid. So molar mass of sulfuric acid So to calculate molar mass, we first determine relative formula mass. So RFM of sulfuric acid is H2SO4. So within sulfuric acid, we have 2 atoms of hydrogen. And each atom of hydrogen, H equals 1. Hope you see this information in the bracket. Capital H equals 1. So sulfuric acid has 2 atoms of hydrogen, and each atom of hydrogen is 1. So we shall have 1 times 2. This 1 is for hydrogen. The 2 comes from there are 2 hydrogens. There are 2 hydrogens, but each is 1. Then capital S is 32. From the information given in the bracket, then O, capital O is 16, but there are 4 of them, so we shall multiply by 4. So summing all these things together, we get 98. So for relative, RFM means relative formula mass. For relative formula mass, it is 98. Relative formula mass is a ratio. It is measured with respect to mass of carbon 12 isotope. So for it, it is a ratio. It has no units in simple terms. So RFM of anything has no units. However, molar mass or formula mass, for example, this has been RFM. So if you want formula mass of sulfuric acid, it is 98 grams. So the difference between RFM and formula mass or molar mass, the difference is in the units. That for RFM, you don't put the G, but for molar mass or formula mass, you include the G. So that is the molar mass of sulfuric acid. Next, you have ammonium sulfate. So RFM of ammonium sulfate looks like this. So it is made up of ammonium, which is NH4, then sulfate SO4. This 2 is coming from the valence of the radical of sulfate. Hope you recall how we are formulating these formulae of compounds. So ammonium sulfate is a compound that has this symbolic representation. So here we have nitrogen, that is 14. From the information given in the bracket, N equals 14. Then hydrogen is 1, but there are 4 of them. So there is this bracket. Since this first bit of ammonium has a bracket, so we also put brackets there. Then we multiply by 2. Why? There is a 2 here down. If you look at this formula carefully. Then next we have S, capital S, which is 32 from the information given in the bracket. Then capital O is 16, but there are 4 of them, so times 4. So summing all these things up, we get 132 as RFM. So if I want molar mass, I add the G. Therefore, molar mass is 132 grams. So basically, those are the few examples that I can give on calculating molar mass. Hope that is clear to you. Next, I think I'm going to first stop here. Then in the next video, the continuation of this video is also on groundwork. Yeah. Because in the next session, I'm going to be looking at some conversions. So video 1 and video 2, that is, they are recaps of what has been covered at school. Yeah. So allow me first to stop this session. Yeah.